everyone and welcome to another new video from the channel Tidbits of Everything. So today I'll be showing you how to make a virtual obstacle avoidance robot. So we need two motors, a breadboard, the LT930D, the Arduino Uno and the ultrasonic sensor. So when we start the simulation over here, for the moment now both the motors are moving forward because there's no obstacle in front of the sensor. But when we reduce the distance over here to under 15 centimeter, which means there will be an obstacle. So now I've made the distance 10.5 centimeter, and now it is minus 143 rpm over here, which means this motor is moving backwards and this is moving front, making it to turn left and move away from the obstacle. So today I'll be showing you how to make this circuit diagram using Tinkercad. But before we get started, make sure to leave a like, share this video to other people and please subscribe as this helps me a lot. So now let's get started. So over here I've opened a new circuit and now we'll start to build the robot. So obviously we'll need our motor driver shield, two motors and breadboard. It will be like the old one, but in the old one we used a 9-volt battery and a volt regulator, which we will not use over here. So now let's add the motor, the breadboard and LT930 to the circuit list. I've added the breadboard, now we'll add the motors. Here is motor 1, here is motor 2. Let me just rotate these motors. So motor 1 is ready. Oh, sorry. And this is our second motor. Yes. So now let's take our L2930 motor driver and attach it on the breadboard. So now, even though we don't have the power to this circuit, let's just make the connecting wires so that when we add the power, the whole thing will instantly go to power. So let's take some positive red wire and do the positive connections first. So do the positive. Positive here, positive here, now let's add the negative connections and attach them to ground. Negative, 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 and negative. Now let's attach the motors to the LT930. But before that, let's connect the both power strips over here. So let's connect it negative and take some red wire and connect positive. Here we go. So now let's get started. I'll just move this connection over. So now let's connect the motors. Let's take some green wire. Connect motor 1's positive to input 1. Okay, now let's connect the positive of motor 2 to input 3. Here we go. And the negative of motor 2 to in output 2. Sorry, not input, output 2. Okay. Now, let's start making the connections over here. So for this project, we need to use a microprocessor, and the most popular microprocessor is the Arduino Uno. We'll be using the Arduino Uno R3. Here we go. So let's connect the inputs to the digital pins over here. So input 1, we'll be using some blue wire for this. Input 1 goes to digital pin 8. The input 2 to digital pin 9. Now input 3 to digital pin 10. Next, let's connect input 4 to pin 11. Now, the most important thing is an ultrasonic sensor which will detect the distance between the object and the robot. So let's just add an ultrasonic sensor here. So there are 4 pins on the ultrasonic sensor. One is the VCC which we will connect to the 5 volts. One is the GND which is negative and will connect to the ground. One is the trigger pin and one is the echo pin. So now the trigger pin will go to pin number 6, 7 and the echo pin will go to pin number 6. Here we go. And echo to 6. Let's just make it okay. So now let's connect the VCC to positive using our red wire and the ground to negative using a black wire. Here we go. So now we will code this. So let's go to code and let's get started. So first let's go to math sorry, I meant let's go to input and let's delete this code over here. So let's set the read ultrasonic distance sensor on trigger pin 0. The trip pin over here is at pin number 7, so we will set this at trip pin 7, and the echo pin is at pin number 6, so let's make the 6 over here. And it will read in centimeter, which is exactly what we need. So now we will take this math block over here and enter it over here. So now it will read the distance. 1 second. So now it will read the distance. Oh, sorry. Yes. So as I was saying, let's just make this pin. Let's just make this code again. Real quick. So trigger pin 7, trigger pin 6. Let's take a match. Okay. So it will read the ultrasonic sensor on trigger pin 6 and the distance. Now we'll enter the distance so that if the distance is greater than 15, let me just extend the size of this. Okay, so it will read the distance and let's make this over here 15. Now the statement at the moment will mean if the distance is greater than 15. So we also need to add a if and then and else command. So here we go. Now we need to control our motors. So input 1 was at pin number 8, input 2 at pin number 9, input 3 at pin number 10, and input 4 at pin number 11. So on the previous video I told you that positive to positive and negative to negative makes the motor go forward. So now since the distance is greater than 15, so there is no obstacle forward, so it can go front. So we will set the pins like pin number 8 should become high, pin number 9 should become low, pin number 9 should be on low, pin number 10 should be on high, and pin number 11 should be on low. So now this will cause the motors to move forward, making the car move forward. But if the distance becomes less than 15, then what will happen? So let's go on to else and we'll make it turn left. So to make it turn left, let's just duplicate this and paste it here. So to make it turn left, input 1 needs to be at negative, input 2 needs to be at positive, and input 3 and input 4 remain the same. So let's make this over here low, which is input 1, and this over here high. So now our code is ready, and now let's start to simulate it. But first, we need to attach the power to the breadboard. So the 5 volt over here is positive, and we'll connect it to the positive of the breadboard. There we go. And let's make this red to avoid confusion. Now, let's take a black wire. 1 second. Let's take a black wire. Let's take G and D and attach that to negative. And let's make this black. So now we have attached the power supply to our breadboard and to all our components. Now let's start the simulation. So as you can see now, the motors are moving forward because the motors are moving backward, which means there is an obstacle in front of the sensor. The left motor is moving backward, which means the car is turning left. That's strange. Yes, so as I was saying, both the motors are moving forward. As you can see, plus 143 and plus 143 because there is no obstacle in front of the sensor. But when we reduce this distance to under 15, then let's see what happens. One second. So let's decrease. And now I've made the distance 12.6 centimeter. And now as you can see, the left motor is moving backward and the right motor is moving forward, making the car go left as there's an obstacle. So this is